When you access WXR platform, you will get login page. You can also make your account here. At this time, we sign up with the prepared account, user 1. This main page shows a significant list of workspaces. Workspaces are workspaces that contain a single scene where multiple users, like chat rooms, can connect to the same workspace and interact with each other through a single work session. These workspaces are listed as bulletin boards and can be paged through the navigation bar at the bottom. Let me explain each column of the table. Functions include an extension button that contains functions related to metadata in each workspace. Title is the name of the workspace, and you can enter the workspace by clicking on the name. Created date is the date the workspace was created, and the owner is username that created the workspace. Size is the number of the users joining in this workspace. Joining does not mean you are participating in a working session at that point. It means that you are able to enter the workspace. The size of just created workspace is 1 because only the owner is joining. Next, there is a role. The user who is joining in the workspace has a role for that workspace. This role is designed with role-based access control and allows you to have some of the predefined privileges. This role is designed with role-based access control and allows you to have some of the predefined privileges, such as reading and writing to the scene, editing metadata in the workspace, and inviting other users. The recent access column displays the date and time of your most recent entrance into the workspace. Finally, the tag column contains short keywords that you attach to express the semantic of the workspace. By clicking on the column head, you can sort the workspace along with the owner, size, and recent access. Click repeatedly to toggle ascending and descending order. In particular, descending sorting based on the recent access is useful because the workspace you've worked on recently is exposed to the top. You can search by name or tag of the workspace through the search bar at the bottom. If you bookmark important workspaces, you can quickly search them by bookmark filtering. By clicking the function button, you can expand it to 4 items. There are buttons to turn the bookmark on or off, to invite other users to the workspace, to manage metadata in the workspace, and to leave the workspace. If the bookmark is already set, the Unset Bookmark button will be seen. Otherwise, the Set Bookmark button will be seen. The button at lower is the Leave button for leaving the workspace. If you are the owner of the workspace, the workspace will be deleted simultaneously, regardless of other participants. I will show you the Invite button and Manage button later. First, I will explain the 2 buttons on the workspace list. Click the Create Workspace button to move to another page, where you can write up the metadata, such as workspace name, tag, description, and more. After filling in all information, you are prepared to create a new workspace. There is a content source field, where the content of the workspace is represented as an HTML formatted code. If you have a pre-built code, you can enter it here to include the initial content. Because tag, description, and content code are nullable, the simplest way to create a workspace is just naming it. Press the Submit button and return to the main page. You can see the workspace you just created and is added to the list. WXR platform can import images, videos, and 3D objects from an external URI. In addition, it provides access control for each asset saved in internal database. The asset manager is an interface to this internal database. Clicking the asset manager button brings you to another page, which is similar to the navigator like File Explorer in Windows. Assets are organized as a tree structure. The root node of the tree is the directory named assets. At the top of this page, path is displayed, and there are buttons for back, forward, and go to parent directory. There are 4 types of asset: directory, target, binary, and template. And there are 2 types of access restrictions: public and private. Public asset is the one that anyone can read and write, and private asset is the one that only you can write and read. Private asset has a whitelist that gives other users read permission, which allows them to load your asset in their workspaces. The top of the right-hand panel shows the current access permission of the asset and type of the asset, and below them, the name of the asset. If you want to modify the name of the asset, you can edit it in this text box and click the Mode button next to it. There are New Asset button and Delete button. The Delete button deletes the currently viewed asset as well as all of its children. The New Asset button expands when pressed, and you choose which type of the asset to create. There is no selection of access modifiers. Except the root directory, the children of public assets are always public, and the children of the private assets are always private. In addition, the root directory does not allow you to create new asset. Only one public directory named public and one private directory with the same name as your username are shown. By giving these constraints, asset path itself implies the semantic of the access permission. If you go into private asset, you will see a share to list on the right panel, which is whitelist with the read permissions mentioned earlier. And you can add users to share through the add button next to it. After a few minutes, we'll be writing our own scenes and showing you the asset uploads. And now, we'll take a further look inside the workspace. This screen shows you accessing the Oculus browser with an Oculus Quest device. If you are using other VR HMD connected to a PC, you can use Firefox browser. As an exception, the Windows Mixed Reality device works normally only with Microsoft Edge browsers. And this time, we will create a new account and log in. This account is currently not joining in any workspace, so the list is empty. The user 1 invites the user 2 to the workspace it created recently. The invitation from the user 1 has arrived. Press join. When you enter the workspace, you can see the left panel, viewport in the right side, and a couple of buttons. The left panel consists of 3 tabs. The Hierarchy tab shows the hierarchy of 3D scenes as in a tree view. The Peer tab lists the users currently being in the session. And the Flags tab shows the status flags and triggers referenced in the user's scenario, as in a tree view. You may notice that nothing is shown yet, because the content is empty now. You can move the camera with WASD key and toggle the hover mode by H button. First, let me add a few primitives into the scene. Press the Insert key on the keyboard or click the plus button on the top right corner to pop up a small window. After typing id, selecting a primitive and pressing OK. And then add a collidable component to the object for making it controllable. And coloring it. If an object is selected, the new object is added as its child. Otherwise, it is added under the scene root. The content is saved in the server database when the upload button on the top right corner is pressed. But even if it is not saved, the job history is temporarily stored in the working session, synchronizing the current scene when someone else comes in this workspace. Scene 1 and Scene 2 are looking at the same synchronized scene. And also, what the user 1 did is synced with the user 2 immediately. Now, user 2 enters the virtual space by clicking the VR mode button at the bottom right corner for an immersive experience. And he tried to manipulate objects through his controller. However, the object user 2 manipulating is out of sync with the user 1, but it also goes back to its place when the user 2 drags the object. This is because user 2 does not have write permissions. Any changes to the scene are not possible unless a new role is granted by another user who has role granting privileges. Because this privilege check is doubled on the client and server, it cannot be bypassed by injecting or manipulating the client-side script. Meanwhile, user 1 clicks the Copy Source button to copy the content source to the clipboard and exits the workspace. User 2 verifies the exit of user 1 and exits the workspace as well. If both user 1 and user 2 exit, the working session will disappear. So when you re-enter, all the work details are rolled back. Now, let's go to this workspace main page. Then paste the copied content source from the clipboard into the content source input box. Then find the user2 in the participant list and assign the lighter role to him. Entering again, you will see that the content source has restored as worked in the previous session. When the user2 tries to interact in VR mode again, we can see that it is performing normally at this time, because the user2 received the lighter role from user1. In VR mode, you interact with the controller. You can use thumbstick for navigation with any hand, and click thumbstick to toggle the fly mode. The direction of the ray on the controller is the same as the direction of tilting the thumbstick. And in no-fly mode, the Y position is fixed by the height value set by the floor and moves in a two-dimensional plane by removing the vector component in the Y direction. When interacting with an object, there are one-handed control and two-handed control. The one-handed control is divided into ray-based and grip-based. When the ray being fired from the controller penetrates the target object, press the trigger button on the index finger. Then, the controller and object move as if they were one rigid body. And when the trigger button is released, they are disconnected again. This approach has the advantage of being intuitive and able to move objects far away. But there may be some least issues because it relies on the direction of the controller when selecting the object. The other approach can be used in close proximity to the target object, and if you press the grip button on the middle finger with the controller overlapping with the object, the controller and the object move as if they were one rigid body. And when you release the grip button, they are disconnected again. In addition, if you hold the same target with both hands, you can pivot around the pivot point of the target object, and if you hold the same target with both hands, you can adjust the scale of the target object. Now, as a more practical example, we are going to create a scene with a scenario that guides you to replace the ball on ball valve. Before that, upload the asset for use in the scene through the Asset Manager. We will make a public asset so that other users can use it. First, upload a high dynamic range image to use in the background. This image will fill the inside of a very large sphere. Next, upload the image for the annotation. Then, upload the border part. Finally, upload two image markers for AR. Now, go back to the workspace created earlier and delete all created objects and save the scene. Add the A-Sky primitive under the root and enter the path of the HDR image you uploaded earlier in the source of the material. Load all ball parts and assemble by adjusting the position. As you might guess from the shape, this handle area is similar to a hinge that rotates around the y-axis. This part will be more natural if you fix it on the axis when operating with VR. A component called VR Snap was devised for these needs, and it attaches like a magnet to a specific location by specifying a certain other object as a target and setting a position vector with attach point. At the moment, it poses with a specific rotation. Then, you will have an axis constraint based on the axis specified by hinge axis. This mechanism only works in VR mode while holding with the grip button. In order to select a target in VR or 3D mode, collision checks such as ray casting are performed, and the target is filtered by the presence or absence of a component called collidable. In this scenario, the base part will not move, so we attach the collidable except this. This scenario consists of 3 steps, and annotations are prepared for each step. Annotations are placed in a good location for each step. Each annotation will become visible, invisible according to the execution step. To do this, attach a transparency component and set the annotation 1 to 1 and the last to 0. The flag tree consists of triggers or flags, which are leaf nodes of the tree, and Boolean values are set or unset from the outside. Any node that is not a leaf node is a trigger and can contain children, and other triggers or flags can come as children. Triggers also contain a Boolean value like flag, which are not accessed from outside but are automatically updated from the flag values of their children. If the trigger type is AND, it is set when all of the children are set. If it is OR, it is set when any of the children are set. In addition, triggers can emit a custom event to the scene root at the moment it goes from 0 to 1 or from 1 to 0. In the scene, such events can trigger animations and so on. In this scenario, we need to trigger a state in which the handle part is turned 90 degrees counterclockwise. The state in which the cover part is out of the initial position in addition to the previous state, and the state in which the ball part is out of the initial position in addition to the previous state. Each trigger is called T1, T2, T3 in order, and each individual state is represented by handle flag, cover flag, and ball flag. I'm going to inverse the ball flag and cover flag. You will see why we do this in a moment. If you check T1 again, you haven't entered an event yet, so enter T1 up, T1 down to distinguish it. Enter T2 as T2 up and T2 down, and T3 as T3 up and T3 down. Return to the hierarchy view and attach the rotation observer to the handle part. This is to set a flag when the rotation becomes a specific value. The goal of rotation is 0, minus 90, 0, giving a tolerance of 0.1 to allow some error. The flag is entered as hash handle flag. Attach a position observer to the cover. When the position reaches the goal value, the flag will be set. But in the case of cover flag, I checked inverse earlier. So when the position is not the target value, the flag will be set. Therefore, The goal value is the position as it is now assembled normally. The tolerance is about 0.01. This value is usually tested for yourself to find a suitable one. Put a position observer on the board as well. Likewise, set the assembled state as the goal value and connect to hashboard flag. Events that occur on the trigger object are always supposed to emit from the scene root. So, any object with a requesting event should let itself capture the event. Attach an event capturer component to annotation 1 and let it capture T1 up and T1 down event. Create an animation for the transparency of annotation 1. Change the transparency from 1 to 0. Enter T1 up for start events and T2 down for pause events. Since autoplay is unnecessary, turn it off and the number of loops is 1 time. Create another animation for annotation 1. The rest are the same as before, but from and to are opposite. And start events and pause events are opposite. Let's do that and turn the handle. You can see that annotation 1 disappears when the handle is turned counterclockwise close to 90 degrees. If you press Ctrl G to return the handle, the annotations will show again. Annotation 2 is similar. The annotation should capture 4 events T1 up, T1 down, T2 up, T2 down. If you need to start step 2 after step 1, it will change from transparent to opaque. And when you complete step 2, it will make it transparent again. Conversely, when step 2 is cancelled and reversed, it should become opaque again. And when step 1 is cancelled and reversed, it will become transparent again. In other words, we want annotation 2 to be displayed only at exactly the steps that need to be performed. The first animation in annotation 2 is an animation that changes from transparent to opaque. And the start events are T1 up and T2 down. Pause events are T2 up and T1 down. The second animation in annotation 2 is an animation that changes from opaque to transparent. And start events and pause events are the opposite of the first animation. Annotation 3 is also similar to annotation 2. It will capture T2 up, T2 down, T3 up, T3 down, and display only steps where you need to do step 3. Enter start events and pause events carefully. Make it the opposite of the first animation. When it's done, I will do the next step from step 1. If you turn the handle first, annotation 1 disappears and annotation 2 appears. Then, if you move the cover further away, annotation 2 disappears and annotation 3 appears. If you undo 3 times with Ctrl G, it becomes the original state again. WXR platform also supports AR mode, which interacts using image tracking. A marker is a primitive for active markers. For source, enter the URL of one of the 2 previously registered targets. The active marker marks its location with a wireframe of a suitable size. Looking at this, weight it and adjust it to the position where the marker will be attached. Attach the target from the handle and put the ID of the active marker just created. The marker and the handle are bound. Now, when the marker moves in AR mode, the handle moves with it. A base is a primitive for base markers. For source, enter the URL of another of the 2 previously registered targets. As for the base marker, transform is meaningless, so the setting is finished. Save the scene and exit. Now, create a new account user 3 on the device that can use AR mode. Invite user 3 to come in. Accept the invitation from user 1. Give the lighter lore so that user 3 can also light. User 2 and user 3 enter the workspace respectively. User 2 enters VR mode and the VR user shows step 1, 2, and 3 in sequence. User 3 enters AR mode and looks at the scene by recognizing only the active marker except the base marker. User 2's demonstration is over. At this time, user 3 doesn't know how to transform the coordinates yet, so it only illuminates the entire scene based on the recognized active marker, and does not allow any manipulation of the scene. When the camera moves, user 3's avatar only moves. User 3 then exposes the base marker, making it possible to perform coordinate transformation internally. Then operate the handle while exposing the active marker well. As the actual handle rotates, the 3D object of the handle also rotates. User 2 can see that user 3 has manipulated the real object through the virtual object tracking it. In a similar way, you can attach an active marker to the cover or board to perform the rest of the steps.